Question, probably as hard as it gets, about the equation of a tangent relating to a circle. Let's go through it step by step. So I've written a few prompts here. Step number 1, what do we know about how the gradient of the radius relates to the gradient of a tangent? Well, actually, that's why I drew this diagram. We know that a tangent meets the radius at 90 degrees, meaning they're perpendicular. So the gradient of the radius is actually minus 1 over the gradient of the tangent. That would mean that the lines are perpendicular. Because it's given you the equation of the tangent, you can take the gradient of the tangent, which is 2, and then write minus 1 over it, what we call the negative reciprocal, and we say that's the gradient of the radius. M just stands for gradient, and then I'm going to write here radius, or rad for radius. Step number 2, we're going to find the equation of the line for the radius. So we already know that it's in the form y equals mx plus c because the radius would be a straight line. We don't know the value of c though. So how can we find c? Well, do we know an equation that the radius crosses through? It actually crosses through this point A because a radius meets a tangent at that specific point. It's labeled P here, but the fact that we know the x and y coordinate, we can substitute that into this equation to find the value of c. So let's do that. y7 is equal to minus a half times 3, which is minus 3 over 2, plus c. After adding 3 over 2 to both sides, you'll get that 7 plus 3 over 2 is actually just 17 over 2. So c would equal 17 over 2. And now we have the equation of the radius, y equals minus a half x plus 17 over 2. Great. How do we use this now? Well, if we look at, well, it's asking us for the equation of the circle to start with. We know that's in this format here. The reason I'm doing all these steps is because although we have A, we have that's the x coordinate of the center, we don't know the y coordinate of the center. Now that we have the equation of the radius, we know that the radius definitely crosses through the center. We can put in the x coordinate for the center, and that will give you the y coordinate at the center, because we know the radius again definitely crosses the center. So replacing x with 5 plus 17 over 2, minus 5 over 2 plus 17 over 2 is 12 over 2, which is 6, meaning the center is 5, 6. So doing this whole process has told us that the value of b is actually 6. We're almost at the answer now. We just need to find the radius, and then we can put it into this format. How will we find the radius? Well, now that we know the center is 5, 6, we can draw our own rough sketch. We also know that the point A is on the circle, and that's the coordinate 3, 7. So 3 is to the left of this and higher up, 3, 7. Now it's going to be a very bad circle, but it's horrible. But the idea is that if you find the length of this line connecting the center to the point on the circle, that'll give you the radius. You can form a right angle triangle just like I did here. The difference in x coordinates is 2, the difference in y coordinates is 1. Using Pythagoras, the square root of 1 squared plus 2 squared is square root 5. I just skipped a few steps here. I'm assuming you know how to do Pythagoras if you clicked on such a difficult question. Now if the radius is root 5, that would mean that r squared is just 5. And now we can put into this final equation. We can say x minus the x coordinate of the center, 5, all squared, plus y minus the y coordinate of the center, 6, all squared equals r squared, which is 5. Again, this is a very difficult question. I saw this in the past exam paper as one of the last few questions, but I hope that made sense. And please like the video if you enjoyed it. Be sure to comment. I'll respond to your comment. And yeah, I've linked my email in the description as well. If you have any tutoring inquiries, be sure to hit me up.